All right, welcome back to CCNA 2. We're going to go over section 1.2. We're going to talk about configuring switchboards. So, duplex is a very, very important thing now. Today, 99% of the world is full duplex. However, you may come into a situation where there's some kind of issue with either half duplex and full duplex mismatches, or having the issue where negotiation fails for some reason between maybe different vendors of products, and that could cause an issue, right? So full duplex is really just communication being able to be sent and received at the same time. Half duplex, of course, is one or the other. Think of it. I guess walkie-talkies aren't so popular anymore, but they used to be. Old radios and walkie-talkies, you could only either talk or you could hear. You couldn't talk and hear at the same time like you can on cell phones today. In fact, a lot of phones like this one are actually half duplex to where you don't realize it, but when you're talking, you can't actually hear the other person. And most of the time, that's what separates a desk phone from a conference phone. The conference phone has full duplex, whereas the phone has half duplex. Now, when I'm talking about that, I'm not talking about from a networking perspective, that's from a voice perspective, but I think you get the point. So we don't have to worry about those collisions when we're dealing with full duplex. We only have to worry about them in half duplex. So half duplex is unidirectional, just like unlike, full duplex. Half duplex is going to create performance issues, make things slower. You're going to have potentially collisions, so that could cause problems and make things even slower than that. Gigabit or 10 gig require full duplex, period. So only 100 meg or 10 meg or lower, which if you're lower than 10 meg today, I'm sorry, will use half duplex. So 90% of the world, the modern world is dealing with gigabit today, so or higher, gigabit or higher. So this is becoming less and less of an issue. Now, some traditional switches, including some of the gigabit switches, actually will be able to fail back to 100 meg or 10 meg in case you have end devices like that, and that could potentially pose an issue. But well, you're getting further and further away from those speeds and half duplex as a whole. It was actually an issue where an end device was half duplex and a newer Cisco switch didn't support half duplex at all, which I thought was absolutely hilarious. But not the people who bought those end devices that were half duplex. They didn't think it was hilarious. So duplex and speed kind of go together. We can manually set these, or they can be auto-negotiated. So typical options are 10, 100, 1000, right? 10 meg, 100 meg, or 1 gig, and either half or full duplex for 10 or 100, and only full duplex for 1 gig. Keep that in mind. That is a great question for the test. Is okay, which one of these does not belong? 10 half duplex, 100 full duplex, 1000 full duplex, or 1000 half duplex? And you go, it's 1000 half duplex because gigabit cannot do half duplex. So auto negotiation should automatically figure this out. Okay, do you support full duplex? Well, we do too. That's great. We'll use full duplex. Okay, do you support 100 meg? Do you support 100 meg and a gig? Okay, well, we support a gig, so we can go all the way up to a gig full duplex. Great. So basically, that's how the conversation goes. This is what I support, and the other guy says this is what I support, and they pick the highest they both support, and then they set that automatically. And it works most of the time. Occasionally, there can be issues, but most of the time, it works pretty well. Mismatch settings could cause connectivity issues, really weird errors, intermittent dropping of packets, stuff like that. So keep that in mind. All fiber optic ports only have one speed and are only full duplex. Now, there is another technology I want to just briefly mention, simplex, which logically you'd look at a simplex connection and you would think half duplex, right? So for example, a simplex connection is going to have um, one fiber connection. So instead of having two fibers, one to send and one to receive, it only has one fiber. And so you look at that and you think, half duplex, you can either send or receive because only one fiber. Now they do this trickery where they have different um, frequencies of light. So we use colors to talk about them. So maybe you could say this is green and this is blue, right? And so we would send on green and receive on blue, and then this guy would send on blue and receive on green on the other end. And so this is kind of a cool way for ISPs to get a little bit more out of the fiber they've got in the ground that's really, really expensive to put in more. They can get a little bit more out of it what they already have in the ground. And this can become very, very valuable when putting in new fiber can cost thousands or millions of dollars, especially when you're dealing with regulations and digging up existing conduits and potentially damaging other conduits and stuff like that, especially when you're talking about high density areas, downtown areas, urban areas. Those areas are riddled with all kinds of pipes and undocumented things very commonly. So it can be a very, very large pain in the butt to put in new fiber. So, for instance, if we wanted to configure these things, we go into config mode. We can go into a particular interface. You have to do this individually. Now, you can do an interface range if you so desire, but if you're doing an interface range and manually setting this, I would be very concerned about what's going on in your network. And of course, you can set the duplex by typing duplex and then either half or full. And then you can set the speed and put the number there, 10, 100, 1,000. And then, of course, you would end. And don't forget to save your configuration, or that super secret command WR, which is my very favorite. AutoMdix is one of those technologies that I love to say saved my butt before I knew it existed. So AutoMdix realizes that we have this issue. So we have a switch here and a switch here, and we have this cable that we run through it. And well, this cable is, transmitting on 1 and 2 and receiving on 3 and 4 on this end. And this one is transmitting on 1 and 2 and receiving on 3 and 4 on this end. So that poses a problem, right? We can't send all on the same pins and receive all on the same pins. So we have to use that crossover cable, right? That crossover cable, however, makes it complicated because now we have to go buy a different cable, or we have to make our own cable. We could forget potentially. This could cause a lot of issues. So Cisco created this technology, AutoMdix, which basically just says, hey, if you notice that it's a straight through cable instead of a crossover on a switch, this is a switch technology. It is not a router technology. It is only a switch technology. So make sure if you're connecting a router to a router, you use a crossover cable, or a router directly to a PC, use a crossover cable. However, if you connect a switch to a router and you use a crossover cable, for example, it should work because AutoMdix should switch it on the switch itself. So it's a switch technology. It automatically figures out which pins on the other side are sending and receiving and adjusts accordingly. That way we can continue to transmit it. So here's some verification commands. If we want to show our interfaces, we can do that with a specific interface ID. We can show our startup config or running config. These are usually ones you want to avoid when you get into the real world, because these configurations are going to be, hundreds or thousands of lines long, unless you use that wonderful pipe and then, maybe you want to begin, or you want to have a section or something like that. So you can also show flash to see information about the flash file system, show version, right? This shows us about our hardware and software, show history. Those are the history of commands entered. And you can change that setting to have more of a history or less of a history if you want. we can show our IPv4 or IPv6 information about an interface. We can show our MAC address table. Keep in mind, this is a layer 2 technology, right? MAC addresses. So this is a switch technology. You would not have MAC address table on a router. Just keep that in mind. So the running config command can be used to verify the switch has been correctly configured. Now again, in the real world, I usually don't use this command without a pipe and a bunch of other junk here to make sure I specifically am looking at part of the config and not the entire thing, because configs can be very, very massive. I was dealing with a firewall not too long ago, and I think it was about 84,000 lines of configuration. So if that tells you anything about how long configurations and confusing configurations can get, they definitely can, especially on firewalls, security appliances, really big routers that do a lot of ACLs and stuff like that. You can get really, really long, complex configurations. So in this case, we're looking for the VLAN 99 config, and we could have done maybe pipe begin at VLAN 99. Or we could do section VLAN 99 or something like that. And we could see here that the IP address is configured. The IPv6 address is also configured. And if it was shut down, you would see the shutdown command here. So that means that we successfully did the no shutdown command because of the absence of the shutdown command. And of course, here's an example of show interfaces. We can see the line is up, protocol's up. Again, this is layer 1, this is layer 2. Being up, we're using a fast Ethernet port, which if you don't remember, fast Ethernet is up to 100 meg. And it gives us stuff like the MAC address, keep alive, encapsulation, full duplex, 100 megabit per second, right? Remember, we talked to fast Ethernet here, and we have the option of 10 or 100 base TX. And by the way, TX means that it is a copper port. Just FYI, it's a good little note to have. So we can also do the show interfaces command. And we can see, of course, this is layer 2, this is layer 1, this is the same information we saw before. So we talked about that, right? So this part is the hardware layers, what they're saying, layer 1. So if there's an issue with the physical connection, that will be down. If there's an issue with layer 2, say for example, Ethernet, the protocol Ethernet, or maybe we're dealing with another protocol like HDLC at layer 2, that could potentially be a problem there. If it is administratively down, of course, remember that shutdown command must have been issued, or we forgot to do the no shutdown when it was shut down by default. Maybe if we see something like error disabled, that should show a hardware problem. More than likely, I see that, and the only time I've seen that is when I've specifically configured something to be shut down based on a certain case, right? So say, for example, you put in security to where you say, hey, I want to make sure if we get any BPDUs, which is a spanning tree concept. I think we're going to spanning tree in a few modules here, but if we put in a BPDU guard, it will actually put the interface into error disabled and stop it from communicating. Or if you put in one of these, I don't have one laying around here, but a little SFP, if you put an SFP that is not genuine Cisco, a lot of times it will put it into error disabled state until you go and get a vendor unlock code from Cisco to basically say you can use cheap Chinese SFPs instead of the super expensive Cisco ones. And just a pro tip for when you're in the real world, there is an awesome website. If you're not relying heavily on your SFPs, say for example, like me, when I build my networks, there is a ton of redundancy built in. I've got 2 to 4 SFPs that go to the same place, right? So I've got, maybe 4 on each side. And so if one of those fails, it's not a huge deal. So what I can do is I can go and buy $5 SFPs from a website called fiberstore.fs.com. And I can spend $20 on 4 SFPs on this side, $20 on 4 SFPs on this side. So I spent a total of $40. Instead of going to Cisco and spending $200 per SFP. And so if I wanted $200 per SFP and just had one instead of four on each side, then I would be talking $400 as opposed to $40. And of course, if I wanted two, which I usually go with two on each side as a minimum, it would be like $800. So Fiber Store can save a ton of money as long as you're not super worried. Of course, you want to monitor these SFPs, and you want to make sure that, hey baby, you want to make sure that they are working, and if not, you want to make sure you have spares and replace and all that kind of stuff. But if they're $5 a piece, it's not a big deal. So, some different network access layers issues we can have, maybe input errors, CRC error, frame error. You have runts, which are too small packets, so the packet is too small, or frame is too small, we can have a runt. That could cause an issue where it's less than 64 bytes. You have giants, which are above the maximum size of 15, 18 bytes. Now we can modify that to allow giants in some cases if we want them. CRC errors. So if we calculate the checksum and the checksum received and the checksum calculated are not the same, that could pose an error there. And we have the CRCs in our packets so that we can check that there. And then of course other output errors. Collisions, right? If we're doing half duplex, or maybe we have half duplex and full duplex, then we could have a collision. Also late collision, so it could occur after 512 bits, which is pretty uncommon. Usually it's the first couple of bits that collide, but it could be a late collision, which has other consequences. So we talked, hi Ellie. We talked about these runt frames that are too small, giants, CRC errors. So I'm just going to kind of skip past this here. So if we're troubleshooting these kind of issues, we can go through a flowchart similar to this one and say, hey, is the interface up? If it is, then maybe we have to worry about electromagnetic interference. Maybe we have to worry about duplex settings. If it's not up, verify proper cables and connectors, verify the cables are working, and then of course, if it's not, then we probably want to escalate to some kind of person that's going to know a little bit more. If we're at this level, we don't have any more knowledge about this kind of stuff. You may need to, we have in the past hired contractors that come out with very, very specialized equipment. I'm talking like $10,000 plus cable testers that can really go deep into electromagnetic interference and stuff like that and figure out exactly what's going on. And sometimes it just doesn't make sense to have that stuff on hand. So that's it for 1.2. In 1.3, we're going to talk about secure remote access. We're going to talk about SSH and all that kind of cool stuff. I will see you then.